Welcome to the ET322 how-to video for our Lab 1 using the oscilloscope with multisim. Okay, now we're going to do a sine wave on our scope. So let's open up our function generator, and there's our piece right here. So we're going to go to sine waves and 3.7 kilohertz. Okay, we don't have in this function generator an ability to go to RMS, root mean squared. So what we're going to do is we're going to start here and we're going to use our scope measurement tool and then go ahead and adjust it. We could go back into our power supplies and grab a sine wave generator, but we're going to do this. Okay, let's start it. And let's go ahead and go to run stop. And we have a nice sine wave there. So let's go ahead and go to our single. And let's add one more. We're going to add RMS. So it's going to say cycle RMS. We're going to go back and it's on there at 3.0. Oh, so good guess. So we're going to go up to, let's say, 4.2 and peak and just see if that's it. I'm not going to do the calculations. We don't need to go that far. I could do that. Let's see, we have 3.07. What are we looking? 3 points? Not even close. Let's try 5. Oops. I'm sorry, wrong box. We do 5.5 here. Sorry about that. And 388. Pretty close. We're going to make it 5.2. Not the prettiest way, but it works. And we got 3.6. I'm going to call that 3.7. So there is our sine wave. Again, our period's going to go from top to the wave, bottom of the wave, wherever it repeats. Okay, and RMS is the average of the area under the sine wave, and we'll cover that later. So let's go ahead and have me trim this out with our snip tool. Make sure that we can see this, and I'm sure it's going to be huge this time again. Always is. Okay, so let's shrink it. And so let's turn off our scope, get rid of that. And since we got it, let's make it big. Okay, 3.7 kilohertz frequency and 3.67 RMS, which turns out to be 10.3 volts peak to peak. Good. Okay, let's do the last one on the lab. The previous one asked us to use cursors. I'm going to go ahead and show you how to do cursors on our square wave. So let's go ahead, and actually this is a rectangular wave. And 10,000 hertz, 10 kilohertz, and 8 volts peak to peak. So we're going to get 4 volts peak. And we'll change the duty cycle here in a minute, but we're going to start with 50%. So let's go ahead and fire it up. Find our scope. Good. And we can move this over. And we still have our settings here. So we have the period 100 microseconds, frequency 10K, and I'll go ahead and let's get rid of the cycle RMS, and let's go time high, positive width, and let's go time low, negative, or minimum. Whoops, not minimum, it's going to be negative width. Alrighty, and we could calculate this to find the duty cycle. So I could take the positive width divided by the period. So we have 50 divided by 100 is 50%. So we could utilize this in order to change the duty cycle. So there's a couple ways we do that. First thing let's do is take a picture of this guy to make sure that it's going through. Okay. And again, it's going to be huge, so let's go ahead and zoom out. Let's turn that off. And let's take our scope out of the way. And here's a good picture of that. 10 kilohertz, 8 volts peak to peak. Alright, so we have 4 volts above the 0. And if you notice here, we have 2 volts, and that's 2 volts to per division. So each one of these boxes, so we got 0 volts, 2 volts, 4 volts. 0 volts, minus 2, minus 4. And we have 20 microseconds. Alright, so our period's 100 microseconds, so we're going to go from pulse to pulse. So let's go ahead. Well, we got 1, 2, 3, 4, 5. 5 times 20 is 100, so that would be our period. Okay, so let's go do our next one. So let's get rid of this, and let's change our duty cycle to 70. Okay, and restart it. Bring back our scope, and let's get a little more. There we go. So let's go ahead and make a copy of that again. Make sure that you can see the good stuff. And let's take him out of the way. All right. So here we have our 10K, 8 volts peak to peak. Period's the same. But if you look here, we're looking for 70% duty cycles. If you look now, we have a positive width of 70. So if we do 1, 2, 3, and some more, that would be 70. So if you have 70 divided by 100, multiply it by 100 and move the decimal point, you have 70%. Good. Okay, that was using measure. Let's go ahead and use our cursor. So we're going to push our cursor button, turn it back on. Oops, let's turn our multi-sim on, get it back running again. Good. So let's go ahead and single sequence it so that we could dial it in. And let's go ahead and, yeah, there you go. Square it up a little bit. So our cursor, we are interested, well, we know the amplitude, we could count that, 8 volts. So let's go ahead and go to time. So you got source, channel 1, voltage, time. So we're going to do time, and you see these 2 green lights come on? That means that they're active. So let's go ahead and we're going to measure the period. It's 100. So let's go over and measure the, there we go. So we have cursor 1 at minus 100, cursor 2 at minus 30, and the delta is 70, and that's what we want. So let me take a picture of that. And let's get him out of the way. And we can see that we have 70 microseconds. Okay. And we could do the same thing. We could do the same thing for the smaller width. Let's bring it back. And let's go ahead and continue to move our cursor. So let's move, come on, there we go, and then move this guy over there. And 29.4 microseconds. I could dial it in a little bit, but it's basically 30. So that's how you use cursors.